Okay, this is a short video to portray the Tucon 2500 evaluating an ammunition bullet shell. Trying to demonstrate the new Z-axis recognition feature for this particular system. So this is a frame. You can see we have a bullet shell, single bullet shell fixture in position. An ammunition shell mounted in place. This is what the shell looks like. We're here on the computer screen. We have a series of test functions that have been predefined by me as the user, the software. And so this program is basically an instruction set to define 5 indentations. We're going to make 5 indents along this bullet shell. The tester will automatically adjust for the varying heights, the larger OD and then the necking portion of the bullet shell, which hopefully you can see in the fixture. Okay. And moving back over to the software, to execute our test program, the user would simply move over to the auto button, and then they would key in some sample information, so your sample name, order number, batch number, what have you, and then they would just press the new sample button. And as soon as you do that, the software will take over under program control, and automatically we will view the specimen, the bullet shell, on our computer. There's a camera mounted inside of our frame, and we can navigate using our XY table. We can navigate any which way we'd like. And we can quickly and easily define our starting location. We'll navigate to that point. I can press the spacebar, the keyboard, and I now get a crosshair approach. The user can now just press enter. And at this point on, the software is completely taking control, and our tester will now make a series of indentations along the bullet shell. So what I've programmed in here, this particular application, is to do 4 indentations on the larger OD of the bullet shell, and then a final indentation on the necking end of the shell. So you can see the system is now quickly moving over to each location. I've set the dwell time to comply to the ASTM and ISO standards, so it's set to 10 seconds. The dwell time is variable, though we can change it to whatever the user may desire. Indentations are being made. We're on our 3rd indent. You can see here on the software it says that we're on our 3rd indent. We've made 2 and we're indenting our 3rd, showing you the status of the indentation. And the indenter will retract. The stage is automatically navigating to the next location. We're making our 4th indentation on the OD. And then for the Z-axis recognition portion of this this test program, the 2500 will actually recognize the change in height based on my program control. So I just told it that this last indent is at a different height, and you can see that we have that necking portion change in height. I'm trying to get the video for you to show it. Change height and move over to the necking portion of the bullet shell. All 5 of our indentations have been completed. Our stage will now navigate back to its first indentation location. The tester rotated to our 20x objective. Moving back over to the computer monitor, you can see that the software is now automatically focusing. And we're automatically measuring each indentation. So now the stage will move back again, image will display, and we will observe the software collecting the measurements. Now for this particular bullet shell, I apologize, the sample has been tested quite a lot. It's got a lot of scratches on it, which can affect the algorithm. So, but it has been very repeatable up till this short video. Also, with the relatively soft material and the 2.5 kg load, the indents become a little bit rounded, which makes it difficult for the algorithms. Just trying to show the measurement capabilities here. It's auto-focusing. It's a nice indent. And this is the very last position. You can see now we're at the necking portion of the bullet shell. Back over to the software, and you can see the indentation is now automatically measured. Okay, so what we're left with is our data, which could then be easily exported to different programs such as Microsoft Excel, or a predefined template using crystal reports. We also have this custom bullet shell fixture, which we also have available. So for this video, I just used a single bullet shell fixture to get the idea that the changing of the height of the z-axis. But what you could do is you could also use coordinates and mount this fixture on our XY table. And you can see here, I'm trying to do this while holding the camera. You can quickly and easily insert the bullet shell. I don't know if I can do this with one hand. It's very difficult to do with one hand, but the idea is that you can quickly and easily mount each bullet shell into this 5 bullet shell fixture, mount the fixture on the stage, and just go ahead using coordinates, quickly load 5 bullet shells, define one starting location, and you're off and running. The software will take care of the rest, and you'll have all your data. Okay, so thank you very much.